Every major religion in human history has taught forgiveness as a moral virtue. Every therapist recommends it. What none of them usually explain is what forgiveness actually is at the level of blood chemistry, nerve conduction, inflammatory markers, and gene expression. Because forgiveness, measured with instruments rather than described with philosophy, turns out to be a specific physiological event, a shift in the operating state of the nervous system, a measurable change in the chemistry of the blood and the inflammatory status of every cell in the body. The person who carries a grudge for 20 years is paying a biological cost that accumulates in cardiovascular risk, immune suppression, and altered gene expression. The person who forgives is releasing a threat signal their nervous system has been maintaining at significant metabolic expense. And there is a nerve, the longest in the human body, that carries the signal of that release to every organ it touches. That comes later. So does a finding from UCLA about what decades of carrying the signal does at the molecular level inside the DNA itself. The body first, what it is actually doing while it carries. Start with the stress response itself, because the architecture that forgiveness releases is the same architecture that keeps you alive. And the crucial difference between forgiveness research and trauma research is this. In trauma, the threat signal is triggered by events the person cannot control. In unforgiveness, the threat signal is triggered by a memory the person is replaying voluntarily, going over the grievance, rehearsing the confrontation, re-experiencing the betrayal. The body's response is identical. The source is different. The source is a memory being maintained by the person's own cognitive processing, and that means the person has the ability to change the signal. Your body's threat response evolved to handle dangers that last minutes. A predator appears. A confrontation erupts. The hypothalamus, a small region at the base of the brain, detects the threat and releases corticotropin-releasing hormone, CRH. CRH travels to the anterior pituitary gland, which responds by releasing adrenocorticotropic hormone, ACTH. ACTH enters the bloodstream and reaches the adrenal glands, which sit on top of the kidneys. And the adrenal cortex responds by releasing cortisol, the primary glucocorticoid stress hormone. This is the HPA axis, hypothalamic pituitary adrenal, and it is a cascade. Each step amplifies the previous one, producing a cortisol surge that reaches peak concentration in the blood within 15 to 30 minutes of the initial threat detection. Cortisol does specific things to the body, and you have felt every one of them during moments of anger or confrontation, even if you did not have a name for what was happening. It binds to glucocorticoid receptors distributed across nearly every tissue in the body: brain, heart, lungs, gut, immune cells, blood vessels. The binding triggers a coordinated shift in the body's operating state. Blood pressure rises as blood vessels constrict, heart rate increases, glucose is released from liver stores into the bloodstream for immediate energy, inflammatory pathways activate to prepare for potential tissue damage, and the immune system shifts from long-term surveillance hunting viruses, monitoring for cancerous cells, to short-term emergency response. Simultaneously, cortisol suppresses every system the body considers non-essential during an emergency. Digestion slows, reproductive function decreases, and the prefrontal cortex, the region responsible for careful reasoning and perspective-taking, is partially inhibited as the brain redirects resources to faster, more reactive circuits. Consider what you have felt during an argument: tightness in the chest, difficulty thinking clearly, loss of appetite afterward, the sense of being physically wound up for hours after a conflict has ended. Each of these is a specific cortisol-mediated physiological event, the glucocorticoid receptors binding in the cardiac tissue, in the gastric lining, in the prefrontal neurons, producing the sensations you have learned to call anger or stress or being upset. The words are imprecise. The physiology is exact. All of this is appropriate for a threat that lasts minutes. The predator is outrun. The confrontation ends. Cortisol levels drop. The parasympathetic nervous system re-engages. The body returns to baseline. The system was designed for this cycle: threat, response, resolution, recovery. The cycle takes roughly 90 minutes from activation to full return to baseline under normal conditions. Here is the problem, and this is the physics that connects stress research to forgiveness research. The brain cannot reliably distinguish between a physical threat and a psychological one. The memory of a betrayal activates the amygdala. The anticipation of encountering someone who harmed you activates the amygdala. The replaying of an old grievance, going over the event in your mind, rehearsing what you should have said, re-experiencing the anger or humiliation activates the amygdala. And every amygdala activation triggers the HPA axis, cascade, CRH, ACTH, cortisol, an identical shift in the body's operating state indistinguishable from the response to a physical attack. The threat is a memory. The stress response is real. And if the memory recurs daily, if the grievance is revisited every time you see the person's name, or drive past a certain place, or lie awake at 3 in the morning, the HPA axis is being activated daily. The 90-minute recovery cycle never completes, because the next activation arrives before the previous one has resolved. A grudge, in precise physiological terms, is a threat signal the body is maintaining continuously. The cortisol remains elevated not at the acute levels of a full fight or flight response, but at chronically elevated levels that keep the HPA axis partially engaged. The inflammatory markers remain elevated: C-reactive protein, interleukin-6, tumor necrosis factor alpha, all measurably higher than they would be if the threat signal were absent. The blood pressure remains elevated, the vessels constricted by cortisol-mediated sympathetic tone, the heart working against higher resistance with every beat. The immune system remains shifted toward emergency response and away from the long-term surveillance that catches viruses and abnormal cells early. The body is running a program designed for a sprint, and it has been running it for years. Thermodynamics makes this concrete. The brain consumes roughly 20 watts, about 20% of the body's total metabolic budget. The stress response system draws from that budget every time it activates. Cortisol synthesis requires cholesterol conversion in the adrenal cortex, an energy-consuming enzymatic process. The inflammatory cascade requires protein synthesis in immune cells, cytokine production, consuming glucose and amino acids. The cardiovascular adjustments require the heart to work against higher vascular resistance, more mechanical work per beat, more oxygen consumed per minute. A single acute stress response costs the body a measurable metabolic surcharge that is recovered within hours. A chronic stress response, the kind to maintain grudge, produces costs that surcharge continuously. Day after day, year after year, the body is diverting metabolic resources from maintenance, repair, and immune surveillance toward an emergency that exists only as a pattern of neural activation in the amygdala. The grudge has a caloric cost. The body pays it in resources that would otherwise go to keeping cells healthy. You may know exactly who this describes. There may be a name, a face that arrived in your mind before this paragraph began. A family member, a former friend, someone who wronged you in a way that time has not resolved, whose memory still produces the specific physical constellation, the tightening in the chest, the clenching of the jaw, the heat that rises when the name is mentioned. That constellation is the HPA axis activating, the cortisol binding to glucocorticoid receptors in your cardiac tissue, your gastric lining, your immune cells. The emergency program running. Every time you think of them, the program runs. Every time you rehearse the grievance, what they did, what you should have said, how unfair it was, the program runs again. And the body cannot tell the difference between the memory and the event. As far as the cortisol is concerned, the betrayal is happening now. Charlotte Whitvleet, a psychophysiologist at Hope College, designed one of the most direct tests of what unforgiveness does to the body in real time. She asked participants to think about people who had wronged them, to replay the grievance, to imagine confrontation, to dwell in the anger and resentment they carried. While they did this, she measured cardiovascular responses, skin conductance, and facial muscle tension with electrodes attached to their skin. Heart rate increased, blood pressure rose, Skin conductance spiked, a direct measure of sympathetic nervous system activation, driven by a cortisol cascade indistinguishable from the one a physical threat would produce. Facial muscles tensed in patterns associated with anger and distress, the corrugator supercilii above the eyebrows contracting, the orbicularis oculi around the eyes tightening. Then she asked the same participants to shift to forgiving imagery, to imagine understanding the person who wronged them, to release the resentment, to wish the person well. The shift in instruction took seconds. The shift in physiology followed within minutes. Heart rate dropped, blood pressure decreased, skin conductance returned toward baseline, facial muscles relaxed. The body responded to the cognitive reclassification as directly as it would respond to the removal of a physical threat because, as far as the HPA axis was concerned, a physical threat was exactly what had been removed. The speed of the physiological reversal matters. It means the body was not damaged by the unforgiveness in a way that required healing. It was being actively maintained in a stress state by the ongoing threat signal, and the moment the signal changed, the physiology changed with it. The stress was not a wound, it was a program being run. Forgiveness stopped the program. Chronic profiles are more consequential than acute shifts. People who carry grudges habitually, who maintain grievances as a stable pattern rather than releasing them, show measurably higher resting levels of pro-inflammatory cytokines, lower heart rate variability, and higher resting blood pressure. Kathleen Lawler and colleagues at the University of Tennessee documented this across subjects with high and low dispositional forgiveness, a stable tendency to release rather than maintain grievances. Interleukin-6 and C-reactive protein are not abstractions. They are measurable molecules circulating in the blood, inflammatory signals that, when chronically elevated, contribute to arterial plaque formation, insulin resistance, and the kind of low-grade systemic inflammation that gerontologists now identify as one of the central drivers of age-related disease. The difference between a forgiving and unforgiving person, measured at the cellular level, was a difference in chronic inflammatory state, the identical inflammatory state that cardiologists measure when assessing cardiovascular risk, that endocrinologists measure when assessing metabolic health, that oncologists recognize as a permissive environment for tumor development. The forgiving person's body was running a lower inflammatory load not because of diet or exercise or genetics, but because the threat signal that drives inflammation was being maintained less often and released more readily. Put directly, the act of releasing a grudge is, measurably, an anti-inflammatory intervention. For a 65-year-old viewer, this carries particular weight. The inflammatory burden that accompanies aging, what researchers call inflammaging, is already elevated by the biology of aging itself. Every additional source of chronic inflammation adds to that baseline. A maintained grievance is one such source. Its contribution is measurable, its mechanism is specific, and its removal through forgiveness is, as Whitfleet's data showed, achievable within minutes once the cognitive shift occurs. Heart rate variability deserves particular attention here because it is one of the strongest predictors of cardiovascular health and longevity available to clinical researchers, and it connects forgiveness to the physical heart in a way that is measurable with a wristwatch sensor. Heart rate variability measures the beat-to-beat variation in the intervals between heartbeats, specifically the respiratory sinus arrhythmia, the natural speeding and slowing of the heart that occurs with each breath cycle. When you inhale, heart rate increases slightly. When you exhale, it decreases. This variation is driven by the vagus nerve modulating cardiac rhythm in real time, the parasympathetic signal slowing the heart on each exhalation, the withdrawal of that signal allowing acceleration on each inhalation. High variability indicates strong parasympathetic influence, the vagus nerve actively and flexibly regulating the heart, the nervous system able to shift rapidly between activation and recovery. Low variability indicates a system stuck in sympathetic dominance, the heart beating at a more rigid, less modulated rate, the vagus nerve suppressed, the nervous system less able to recover from stress. Clinically, Low heart rate variability predicts cardiovascular events, heart attacks, strokes, arrhythmias, with a reliability that exceeds many traditional risk factors. It is a measure of how flexible the nervous system remains, how efficiently it can shift between states, how much parasympathetic reserve the body retains. Chronic stress suppresses heart rate variability. Chronic unforgiveness, as a form of chronic stress, suppresses heart rate variability. Lawler's data showed that dispositional forgiveness was associated with measurably higher heart rate variability, a more flexible, more resilient, more clinically protected cardiovascular system. Now, what forgiveness actually is, at the level of neural circuitry, because the word carries so much moral and religious weight that the physiology beneath it has been almost invisible. Forgiveness, neuroscientifically, is the decoupling of a memory from the threat response that memory has been triggering. The event remains encoded in long-term memory. The person who caused harm remains remembered. What changes is the amygdala's classification of the memory. The tag that was reading active threat is reclassified to historical event. Fred Luskin, who developed the Stanford Forgiveness Project and guided thousands of people through forgiveness interventions over 2 decades, describes this as the moment the brain reclassifies a grievance from an active danger to a historical fact. Luskin's clinical observation was that the reclassification rarely happens through willpower alone, through gritting your teeth and deciding to forgive. It happens through a specific cognitive shift. The person stops telling themselves a story in which the grievance is central to who they are, and starts telling a story in which the grievance is one event among many painful, real, but no longer the organizing principle of their emotional life. In the Stanford Forgiveness Project, Luskin guided subjects through this shift across multiple sessions. The results were measured physiologically. Participants who completed the forgiveness intervention showed reduced blood pressure, reduced self-reported stress, and critically reduced frequency of intrusive thoughts about the person who harmed them. The reduction in intrusive thoughts is the behavioral correlate of the amygdala reclassification, the memory surfacing less often because the threat tag has been removed, the brain no longer scanning for the danger that the memory had been signaling. The shift is not instant. It is not easy, and it does not require the person who caused harm to apologize, to change, or to deserve forgiveness. The reclassification happens inside the brain of the person who forgives, independent of anything the other person does or does not do. Neural correlates of this shift are measurable. Reduced amygdala activation in response to the memory of the person who caused harm, and increased prefrontal cortex activation, the region that provides context, perspective, and the regulation of emotional responses. The amygdala stands down. The prefrontal cortex takes over the processing. The HPA axis, no longer receiving a threat signal from the amygdala, stops generating the cortisol cascade. The body receives the news through every glucocorticoid receptor in every tissue. The emergency is over. The shift does not erase or excuse. It does not require reconciliation or renewed contact or the pretense that what happened was acceptable. It requires only that the brain's threat detection system stops treating an old memory as a current danger. The memory persists. The story persists. The person who caused harm remains remembered with full clarity. What stops is the cortisol. What stops is the inflammatory cascade. What stops is the body's emergency response program running against a threat that exists only in the past. The event becomes, in the brain's filing system, something that happened, not something that is happening. And the body responds to that distinction with the immediacy of a system that has been waiting for permission to stand down. Anyone who has forgiven someone after years of carrying the grievance knows what this change feels like in the body. Something lifts, the chest loosens, the shoulders drop. The constriction that had been present so long it had become invisible suddenly becomes visible by its absence, the way you only notice background noise when it stops. That sensation has a precise physiological description: vagal re-engagement. the parasympathetic nervous system coming back online after being suppressed by chronic sympathetic activation, the heart rate slowing slightly and becoming more variable, the breathing deepening as the diaphragm relaxes, the gut resuming motility that the sympathetic system had been suppressing. Some people describe a physical sensation of warmth spreading through the chest and abdomen in the moments after genuine forgiveness. That warmth is vasodilation, blood vessels relaxing as sympathetic vasoconstriction decreases, blood flow increasing to the visceral organs as the parasympathetic system resumes its regulation of circulation. The sensation is as physically real as the constriction that preceded it. The body is not speaking in metaphors. It is reporting a change in vascular tone, cardiac rhythm, and autonomic balance, a change that registers in subjective experience as relief, as lightness, as something having been put down. Cranial nerve 10. The vagus nerve is the longest cranial nerve in the human body. It originates in the brainstem and descends through the neck, branching to innervate the heart, the lungs, the esophagus, the stomach, the intestines, and the liver. It carries both afferent fibers sending sensory information from the organs back to the brain, and efferent fibers sending regulatory signals from the brain down to the organs. Roughly 80% of its fibers are afferent. The vagus nerve is primarily an information highway running from the body to the brain, reporting on the state of the internal organs and feeding that data into the brain's ongoing assessment of whether the body is safe or under threat. Vagal tone, the baseline activity level of the vagus nerve, is what heart rate variability measures. High vagal tone means the parasympathetic system is actively modulating cardiac rhythm, digestive function, and immune activity. The body is in recovery mode, digesting, repairing, running the long-term immune surveillance that catches abnormal cells and viral infections early. Low vagal tone means the sympathetic system is dominant, the body is in threat response mode, suppressing recovery functions in favor of emergency readiness. Chronic stress, including the chronic stress of maintained unforgiveness, suppresses vagal tone. The sympathetic system stays engaged. Recovery is inhibited. The heart beats at a more rigid rate. Digestion operates less efficiently. Immune surveillance is suppressed in favor of the inflammatory response. The body is paying a daily maintenance cost for a threat signal that has no resolution because the threat is a memory, and memories do not end the way predators do. The predator is outrun, and the HPA axis stands down. The memory recurs, and the HPA axis activates again. The cycle has no natural endpoint. For a person who has carried a grudge for 20 or 30 years, the vagal suppression has compounded across decades. Vagal tone naturally decreases with age. The parasympathetic system becomes less efficient as part of normal aging. A maintained grudge adds a second source of suppression on top of the age-related decline. The person carrying a 30-year grievance into their 70s has a vagal tone suppressed by both aging and chronic stress. Simultaneously, two forces of parasympathetic inhibition compounding in the same nervous system. The cardiovascular risk associated with low vagal tone is already elevated by aging. The grudge elevates it further. And the release of that grudge, the forgiveness that allows vagal tone to recover, removes the second source, allowing the parasympathetic system to operate at whatever capacity aging has left it. Forgiveness, by releasing the threat signal, allows vagal tone to recover. The parasympathetic system re-engages. Heart rate variability increases. The heart returns to its natural modulated rhythm. Digestion improves the gut, innervated by vagal efferents, resumes normal motility and secretion. Immune surveillance resumes. The cells that hunt viruses and monitor for abnormal growth return to their long-term patrol. The body, which had been locked in threat response mode continuously, is permitted to return to the operating state it was designed to occupy most of the time. If you have ever carried a grievance for years and then released it, genuinely released it, through whatever process brought you to that point, you may have noticed changes you could not fully explain. Better sleep, easier digestion, a sense of physical lightness that had no obvious cause. These are not metaphors. They are the vagus nerve re-engaging with the organs. It innervates the cardiac rhythm, becoming more variable, the gastric motility normalizing, the respiratory pattern deepening as the parasympathetic system takes back territory from the sympathetic dominance that the grudge had maintained. Every organ the vagus nerve touches receives the signal of that release. The shift happens in the amygdala. The signal travels down the vagus. The organs respond. The body you are sitting in right now knows the difference between these two states, threat and recovery, because it has lived in both. The vagal system that carries the shift is already wired. The only variable is the signal the amygdala sends. That is what forgiveness does in the minutes and hours after it occurs. What happens across years and decades operates at a different scale entirely, because the cellular cost of carrying the threat signal for decades is written into the DNA itself. Steve Cole at UCLA, studying the genomic effects of chronic perceived threat, found something that connects stress research to molecular biology in a way that changes the scale of the conversation entirely. Cole did not study forgiveness directly. He studied what happens to gene expression, the process by which cells read their DNA and produce the proteins that determine cellular function under conditions of sustained, perceived threat. His subjects were people experiencing chronic loneliness, chronic caregiving stress, and chronic social threat conditions that, like unforgiveness, maintain HPA axis activation over months and years. What Cole found was that sustained threat perception alters which genes are being read. Specifically, people under chronic perceived threat showed increased expression of genes controlled by the pro-inflammatory transcription factor, NF-kappa B, a protein complex that binds to specific DNA sequences in the promoter regions of inflammatory genes and activates their transcription, producing more inflammatory proteins. Simultaneously, the expression of genes involved in antiviral response and immune surveillance was decreased. The cells were producing fewer of the proteins that hunt viruses and monitor for cancerous growth. NF-kappa B is the molecular switch. Under acute stress, cortisol is anti-inflammatory. It suppresses NF-kappa B and reduces inflammation, which is appropriate for a short-term emergency where the body needs to focus resources on immediate survival. Under chronic stress, the relationship inverts. Chronically elevated cortisol produces glucocorticoid resistance in immune cells, and the receptors become less sensitive to cortisol's suppressive signal, and NF-kappa B activity increases rather than decreases. The chronic cortisol that was supposed to suppress inflammation ends up enabling it. The molecular machinery that reads the genome shifts toward an inflammatory program, more pro-inflammatory cytokines produced, fewer antiviral and anti-tumor proteins produced, and the shift persists for as long as the threat perception persists. What results is a shift in the body's gene expression profile, more inflammatory proteins being produced by every cell that carries those genes, fewer antiviral and anti-tumor proteins being produced by the immune cells that should be running long-term surveillance. The body, under chronic perceived threat, is literally reading its own DNA differently, activating the inflammatory program and suppressing the surveillance program. A grudge held for 20 years is 20 years of shifted gene expression, 20 years of elevated inflammatory cytokines, 20 years of suppressed antiviral and anti-tumor immune function. The biological cost of unforgiveness is paid continuously, in every cell, in the molecular machinery that reads the genome. I keep returning to that number, 20 years. A person who was wronged at 45 and carries the grievance to 65 has spent 20 years with NF-kappa B activity elevated in their immune cells, 20 years with antiviral gene expression suppressed, 20 years with their body's inflammatory load measurably higher than it would have been if the amygdala had reclassified the memory as historical. The cost was invisible, the cost was real, and nobody told them it was accumulating. This does not mean that unforgiveness causes cancer or heart disease. in any simple causal chain. Biology does not work in single causes. Chronic inflammation is one risk factor among many genetics. Diet, exercise, environmental exposures, and chance all contribute. But chronic inflammation is one of the most consistently identified mechanisms underlying age-related disease, cardiovascular disease, type 2 diabetes, neurodegenerative conditions, certain cancers, and one of the drivers of chronic inflammation, measurable in blood chemistry and gene expression profiles, is the chronic HPA axis activation that a maintained grievance produces. The science says, unforgiveness contributes to the inflammatory environment in which disease is more likely to develop, and forgiveness removes that contribution. The contribution is real. The removal is real. The rest is probability, not destiny. For a person who has carried a significant grievance for decades, the biology is not an accusation. Nobody told them this. Nobody explained that the anger they maintained was generating a cortisol signal that was shifting their gene expression profile toward inflammation and away from immune surveillance. No physician mentioned that the tightness in their chest when they thought about the person who wronged them was an HPA axis activation indistinguishable from what a physical attack would produce running at lower intensity, but running constantly year after year with no resolution cycle because the threat was a memory, and memories do not end the way predators do. The body was doing its job. The job was never supposed to last 20 years. The architecture was built for minutes. The grievance ran it for decades. And the science is not saying this to produce guilt, it is saying it to make visible what had been invisible, so that the choice to forgive, if it comes, arrives with the full weight of what the body has been carrying and what the body stands to release. The forgiveness that every spiritual tradition has recommended as a moral virtue turns out to be, simultaneously, one of the most direct physiological interventions available to a person carrying decades of accumulated stress. The moral framework and the biological framework arrive at the same recommendation through entirely different reasoning, and neither one knew about the other until the measurements caught up. Every tradition that has recommended forgiveness was working from observation. People who forgave seemed healthier, seemed to carry less, seemed to move through the world with something the traditions could only describe as grace or lightness or peace. The biology explains what they were observing. The grudge is a threat signal maintained for years, elevating inflammation, suppressing immune surveillance, altering the expression of genes in every cell that carries them. Forgiveness requires, at the neurological level, only one thing: the reclassification of an old threat as a historical fact. The amygdala stands down. The vagus nerve re-engages. The body, which has been spending biological resources on a danger that exists only in the past, is finally permitted to recover. What every religion called virtue, the body calls recovery.